Assalamualaikum students. Today I'm going to deliver the lecture of physics unit number 3 dynamics, and my topic of discussion is force and momentum. The term force can be defined as a force moves or tends to move, stops or tends to stops the motion of a body. The force can also change the direction of motion of a body. Similarly, the term momentum can be defined as the product of mass and velocity is equals to momentum. Here m represents mass and v represents velocity. And our question is, how can you relate force and momentum of the body? So let's start its derivation. Consider a body of mass m is moving with initial velocity vi. Let a force F acts on the body and it produces an acceleration A in it. After time t, the velocity of the body becomes Vf, which is called final velocity of the body. Now we have to calculate the initial and final momentum of this body. As you know, the general form of momentum is P is equals to mv. For initial velocity Vi, initial momentum can be written as Pi is equals to mvi, and for final velocity Vf, final momentum can be written as Pf is equals to mdf. Now change in momentum is equals to final momentum minus initial momentum. By putting the values of final momentum and initial momentum, we can get the change in momentum. Hence, Pf minus Pi is equals to mvf minus mvi, where mvf represents final momentum and mvi is the value of initial momentum. Now, rate of change in momentum is, remember one thing, rate is always obtained by dividing the terms by time t. So, dividing these terms by time t, we get Pf minus Pi over t is equals to mvf minus mvi over t. In the next step, Pf minus Pi over t will be equals to, taking m common, we get Vf minus Vi over t. Now we will have to put the value of this expression. As you remember, acceleration is equals to Vf minus Vi over t, as acceleration is the rate of change of velocities, where Vf represents final velocity and Vi represents initial velocity and t represents the time. Hence, by putting the value of acceleration in this equation, we get Pf minus Pi over t is equals to ma. Also we know that F is equals to ma. So that is the Newton's second law of motion, which is the mathematical form of Newton's second law of motion. Hence, by putting the value of ma, we get Pf minus Pi over t is equals to F, which is the required. Hence, we can say that rate of change of momentum is equals to applied force. Thank you.